Hi YouTubers, this is the second video in a series of videos that I'm creating on building a chess engine from scratch. So let's go ahead and pick up where we left off. In our last video, we introduced the tile class and two of its concrete subclasses, the empty tile and the occupied tile. And we also created the piece class, which right now is just sort of a stub. It's a placeholder. We introduced it in order to get rid of our compile errors because we had a single reference to the piece class via the getPiece method. And I wanted to tidy up this class as I promised in the last video and go ahead and explain some of the conventions that I've used and also cover the topic of immutability and its benefits and modify our class to be immutable. So first of all, everybody will notice that we declared the tile class to be abstract, which means we cannot instantiate this class. We can't say new tile, but we can instantiate concrete subclasses, and we have two in our case, empty tile and occupied tile, and that's fine. The other thing that I want you to sort of take note of is that I have declared the occupied tile and the empty tile inside of the tile file. I could have declared them in a separate file, and I wouldn't have needed to declare those classes static. I did that because I didn't want them to be an inner class with inherited state from tile. I wanted them to be sort of on their own. But as sort of a convention for classes like this, I think you'll find some people will put it in a different file, others will leave it in the same file. I've chosen the latter. So from here, there are a couple things that I want to do. One is that I want to organize my code and put my code in sort of logical packages. If you're not familiar with logical packages, I think you can sort of pick up any introduction to Java book to figure out what that means. But here are the two packages that I'm going to introduce. One is COM Chess Engine Board, and that's where I'm going to place my tile class. And the other is COM Chess Engine Pieces, and that's where I'm going to put my piece class. So here's what we'll do. We'll uncomment this line, and the package declaration needs to be the first line of the class file, and we'll say package COM Chess Engine Board. And so what we could do here, now that the IDE is complaining, is right, so the IDE will do the move for us after we've declared it. And we have one more error here, which is just me commenting that line out. Let's take out the class comment. Doesn't really serve any purpose. And let's go ahead now and copy that. Go to the piece class and replace this with package comment. Okay. And this will complain. We'll sort of highlight the line and let the IDE do the heavy lifting. Right? So at this point I don't really know what to do, but I can sort of come over here and highlight the error, and the IDE will present me with this little red light bulb. I can pick it and I can select the ways to sort of address this error, and the IDE will sort of automatically fix it for me. So in this example, I'm going to move the class to the pieces package. And right now, so the last error that I'm seeing is after I've reorganized my classes, the reference to piece here needs to be qualified. I can highlight this line again, this error, and hit Command Enter, or Option Enter on my Mac, and that will, all that did there was it imported piece, right? So before it was giving me an error, let's undo that, when I undo that, it's saying I don't know anything, I don't know where this piece class is coming from, but the ID is sort of indicating that yes, you do have a piece class. Do you want to pick this com chess engine piece class? And on my Mac I hit Option Enter to import that class, right? So now we no longer have any errors. We still have two classes, tile and piece. Now they're organized in respective packages, which is a little cleaner to look at. And at this point, I want to take the time to introduce the notion of immutability and go ahead and make our tile class immutable. So I've taken the liberty to sort of do a Google search for the immutability concept from the effective Java book that I mentioned in the last video, written by Joshua Block. You can do a sort of a partial search on Google Books. This isn't the complete book by any means, but it's sort of little snippets of the book that you can look at for free. I would highly recommend that you purchase this book. It's a fantastic book, and every programmer should have a copy of this book. So I'm going to go ahead and read to you the snippet on immutability written in this book, and we're going to go ahead and take that and apply it to our class. So let's start right here. Immutable objects are simple. An immutable object can be in exactly one state, the state in which it was created. If you make sure that all constructors establish class invariants, then it is guaranteed that these invariants will remain true for all time, with no further efforts on your part or the part of the programmer who uses the class. Mutable objects, on the other hand, can have arbitrarily complex state space. If the documentation does not provide a precise description of the state transitions performed by mutator methods, it can be difficult or impossible to use a mutable class reliably. Immutable objects are inherently thread safe. They require no synchronization. They cannot be corrupted by multiple threads accessing them concurrently. This is far and away the easiest approach to achieve thread safety. In fact, no thread can ever observe any effect of another thread or an immutable object. Therefore, immutable objects can be shared freely. Immutable classes should take advantage of this by encouraging clients to reuse existing instances wherever possible. One easy way to do this is to provide public static final constants for frequently used values. For example, the complex class, which was introduced above, might provide these constants, right? So if you created a complex class, you can now have these constants for 0, 1, and I, and you would never need to say new complex 0, 0 again. You could always reference this 0 constant. That's what the book is telling you here. This approach can be taken one step further. An immutable class can provide static factories that cache frequently requested instances to avoid creating new instances when existing ones would do. All the boxed primitive classes and big integers do this. Using such static factories causes clients to share instances instead of creating new ones, reducing memory footprint and garbage collection costs. Opting for static factories in place of public constructors when designing a new class gives you the flexibility to add caching later without modifying clients. Okay, and there's a lot more written here that I will encourage you to read about. But knowing what we just read, we can come back to our class. And when I was learning immutability, I was sort of looking for a keyword or something that would say make my class immutable, and that's not how it works. With immutability, you have to you basically have to make it such that you do not provide any way to mutate state on your class object. So let's look at our class object and see what are the things that could mutate, that make our class not immutable. Well, first and foremost, there is the tile coordinate, right? I don't provide a setter method on the tile coordinate, but I didn't declare my tile coordinate to what the visibility of my tile coordinate is. So I could probably declare an instance of a tile coordinate and reference that member field on it and mutate it. And so we want to prevent that from happening from any clients who use our API. So let's go ahead and declare it to be protected so that it can only be accessed by its subclasses. and final. That is to say that once once this member field is set inside of the constructor, we're not allowed to set it again. It can only be set once at construction time here. So we're going to declare this to be final. And the other thing that we're going to do is we're going to come down to our subclasses, and actually, to be, as a convention, we can even also have the arguments to our method constructor be final as well, which I will do. And here we'll look at our subclasses, and we can see that in our subclasses, the field that I have that can be mutated is the piece on the tile. So let's go ahead and make that final as well, and we will say that it's package private. Excuse me, that it's class private. So that means that no one, there's no way to reference this variable outside without calling getPiece on it. And so now here we have a class that for the most part is immutable. You cannot, I challenge you to, obviously I'm doing this live, so I may have made a mistake, but I challenge you to find a way to mutate this class. I don't think you can, and therefore it is immutable. Now that we've done this, what is this bot for us? Well, a few things, but the thing that I want to focus on is this. The point that was made from the book about constants and caching. We can, if we want, create all of the empty tiles that are valid up front, and whenever we want to retrieve one, instead of creating a new one, we could just simply look it up in the cache. Now, so what I'm going to do here is I'm going to declare a new member field, private static final map integer empty tile. Empty tiles is equal to, and I'm going to create a private static method called create all possible empty tiles. Okay, this is a map. Import the Java Util Map class. This method doesn't exist, that's what it's telling us. So let's create this method, private static map, and so now we have our method. And right, so what is this method going to do? This method is going to say final map of integer empty tile map is equal to new hash map, and for int I equals 0, I less than 64, or yeah, I plus plus empty tile map dot put I new empty tile I. Right. And last thing I'm going to do here is say return empty tile map. Now, you could, if you wanted, do this. I want to take the time to introduce a new library that we're going to depend on that's going to make this a little bit cleaner. So I'm going to say immutable map dot copy of empty tile map. Now, right now, IntelliJ is telling me I don't know anything about this immutable map class. Where is this coming from? I don't know where to import it from. That's because we are this doesn't exist in the JDK. This immutable tile map class is part of the Guava library, which is a third-party library provided by Google, which happens to be where Joshua Block works, and that contains this concept. I don't want to spend too much time in this video going over this, but what we're effectively saying is this: that I want an immutable map. A map's a container, right? So if I want an immutable map, it's not enough for me to just return the empty tile map, right? Because I can then, after I've returned the empty tile map, somebody can say clear the empty tile map, put a new value in the empty tile map, and what I want to say is after I've constructed this empty tile map, I don't want anyone to be able to change it. And so Google in their Guava library will allow me to do that. So in order to use that, we need to download it. I'll provide a link to Guava in the description box, but I think I have a copy on my local hard drive here. So what I will do is I'll hit the wrench, go to libraries, and add a new dependency for Java. And let's see, where did I put my copy of Guava? Let me look for it. Oh, it looks like I have a lot of copies. So let's copy version. There's a copy. So let's copy that to my home directory. And let's add a dependency on it. There's Guava. Okay. I think that should do it. So this is still complaining. Let's see. Now we can import the class. Okay. Great. So now I have what I've done here is every possible empty tile that could ever exist, I've created it up front so that I never have to construct them again. If I ever want the empty tile that references the first chest tile, all I'd have to say is empty tiles.get of 0. That would correspond to the very first tile in a chessboard. And if I wanted the very last tile in the chessboard, I'd say empty tiles.get 63. Okay, and so the last thing that we're going to do here is we're going to make the constructors private. Right, so that constructor is private, and so the only way that anyone will be able to create a new tile is going to be via a new factory method that I'm going to provide. Public static tile create tile final end coordinate, tile coordinate, let's say, and final piece. And what I'm going to say is return piece not equal to null, question mark, new occupied tile coordinate piece. Otherwise, empty tiles.get tile coordinate. Oops. So effectively, anyone, really the only method that anyone's going to be allowed to use on my class to create a tile is going to be this create tile method, and if they ever want an empty tile, they're going to get one of the cached empty tiles. Otherwise, they're going to create a new occupied tile. Now, I also want to point out that we could cache all possible occupied tiles, and I will discuss that in a future video. But I think if you've gotten this far and you've understood everything that we've done, then you've made the most of it. Then you're in a good shape. Hopefully that wasn't confusing. But now we have a tile class. So let's summarize what we've done. We've restructured our classes to be more organized, and we've covered the topic of immutability. We've gone ahead and made our tile class immutable. And I'm going to use this convention. I'm going to be asking myself, as I move forward in this exercise, whether the classes I create can be made immutable. And if so, then we will strive to make them immutable. Okay, so let's stop here, and we'll pick it up in the next video.